Yeah, time for reactions from our two reactors. First is Dr. Marco Barla, who is an associate professor of geotechnical engineering at the Politecnico di Torino in Italy, where he is the coordinator of a research group in the field of energy geostructures, laboratory testing on soils and rocks, numerical modeling, tunnel excavation, slope stability, and monitoring. Other than his academic involvement, Dr. Barla is also a consultant and founder of Resolving SRL, an engineering company, which is a spin-off of the Politecnico. And yeah, Dr. Barla is the current, as you know, president of the LGIP, and which is the co-organizer of this Zurich event. And he is also the editor-in-chief of the ASCE International Journal of Geomechanics. For our second reactor, Dr. Katarzyna, is a civil and structural engineer and a researcher. She is an expert in the field of the distributed fiber optic sensing technology at the Nerve Sensors Company, working primarily on solutions for strain and displacement measurement. I think I would especially request Marco to comment on the one point Blaise was raising earlier about the applicability of approaches and models, and because that is also something that was raised very strongly during the earlier discussions, I think it would be nice to have your opinion from the academe in this regard.
Okay, thank you. So you mean about applying modeling in our so the idea of considering modeling. Well, let me say one thing first before addressing that. We are talking about. Before that, I have to say one thing. At 5 to 5, I have to leave. So I already apologize for that.
Don't worry, I will eject
you. Go ahead. We're talking about resilience of these critical infrastructures, and we said you made the definitions, other highlighted some definitions, and yesterday during the dinner, but also today, we said how do we define this resilience? Resilience has a definition. However, in this process, maybe, and modeling is there, in this process, maybe what we really need to do is to quantify this aspect, and because if we need to say, well, we want to make our structures more resilient, and I'm going to Paul's presentation, in fact, the final slide, if you want to make it more resilient, so it's saying I'm here and I want to go there. So in some way I have to say, I have to give a number to this level and another number to the other level to understand if I'm increasing or not. So I work in tunnel engineers, not piles, and so if I try to apply this in my field, I say, okay, what can I do? I have my lining of the tunnel, maybe of an old tunnel. We spoke about aging before, and if I could do like this and change the strength of the lining, then maybe if I have a tunnel of the 60s, the unconfined compressive strength is 10, 12 megapascals or 15 megapascal. I do like this, I take it to 30 megapascal. What have I done? Did I double the resilience of the infrastructure of my tunnel? I don't know. So the point could be, do we need to find a way to quantify this? Because you mentioned about robustness and other terminology, which is probably closer to us, but do we need to find a way to quantify resilience? Is that a work that academia, for example, can do? Because today you clearly said it's not in the codes, and we learned that if it's not in the codes, nobody reads papers, so nobody will use that. So if it's not in the code, do we need to quantify it somehow? Does some PhD students need to work on this topic? I tried to look on the internet on this and found that some people already worked on that, not only in our, not mainly in our disciplines, in social sciences also. Maybe this is a time that we can have a look to what the people in social science did. and try to see if these figures, numbers, equations are applicable to our world. Maybe this can open a path to go and quantify. So that was my consideration. Then maybe I'm going already too long, but I had a query from Tonette to answer, which I don't even remember which one was it, about modeling in this process. Modeling is if I understand well the query, modeling is always in the process of design, because modeling is a idealization, it's a schematic conceptualization of reality. So we as engineers, we need to simplify things. We go for models, and with the word model, we mean many things. It's not the numerical model. It's a conceptualization of it's not only the numerical model. It's the conceptualization of reality. However, modeling is not. Maybe this would be the answer. It's not the only point. Because someone highlighted earlier about monitoring, but also Rosa mentioned it in her presentation. Monitoring the performance means being able to see if what we have designed, if the model we used was appropriate. And so prediction comes from a model. Prediction and performance is what we have to do. Making a prediction, checking the performance, and this I think is the only way of making an let's say an appropriate design. Do I have another minute or not?
You can, yeah. Go ahead.
I can.
Yeah.
So from this point of view, I think that in this area, but taking things from your presentations, in this area, we have two main approach. One is that of improving, allow me to say strength. It's not only strength, of course, but if I look at what you do with earthquakes and structures and so on, that is somehow improving the ability of that structure to support loads. And the other way is to do monitoring or detecting things in advance, as Rosa was saying. And I think that is very, very relevant to the risk resilience of infrastructure when we speak of infrastructure, not only as you said, not only roads, but also energy, water, and whatever. And just to be optimistic, because it's the last session of the day, I think that this fact of saying we have to do something to make our infrastructures resilient because we have global warming, it's also an opportunity. So aging, and it's also an opportunity for us, because it's a time where we can go and see our infrastructures and say, okay, what about if we modify something here? I'm a tunnel engineer again, I say it. I want to change I want to improve my lining, reconstruct partially my lining because of aging. Well, if I do that, I can put sensor in it, I can put fiber optics in it. I can use the new tunnel to understand, maybe with artificial intelligence. I know nothing about artificial intelligence, but maybe it can, for it last 50 years, maybe for the next 20 or 30 years, we'll be able to give some information on its health that we don't have from the last 50 years. So we can improve on that. Then we can do fancy things. I work on energy geostructures. We can get energy from infrastructures. We can find this as an opportunity, just to be optimistic. Then I have to stop.
Okay, thank you, Marco. Maybe now we can hear from Katarzyna.
Yeah, and I would like to continue the way of thinking of Marco and also talk about the structural health monitoring. I'm a bit biased because I'm from a company who is dealing with structural health monitoring, but we really think that now it's the time point where we have two ways to act. The first issue which we are dealing with is the existing infrastructure, and I like it in the presentation of the first speaker of place that the screening of existing infrastructure is a huge topic, and the prioritizing of the retrofit measures is a huge topic, and we need to act on it. And it's of great importance. But on the other hand, going further, we are convinced that the new structure, and now I'm talking about the critical infrastructure first of all, but not only of the critical infrastructure, needs to be equipped with monitoring solutions, with appropriate monitoring measures. And only in such a way we will be able to find out what happened after a potentially disruptive event in relevance to the initial state of this building or of this infrastructure element or of this embankment, of this railway, whatever. As we think it should be mandatory to have some kind of monitoring solutions depending on the object, it also needs to be governed by guidelines, because otherwise the owners of the critical infrastructure and the owners of other objects, they will not be so keen on investing of it at the beginning, because the short-term investment is sometimes really the obstacle, even if everyone is aware that the long-term benefit will be higher. And if we consider here the definition which Tonette presented at the beginning, that the resilience is the ability to rapidly recover from a disruptive event. And I was really astonished to see that in the list of these disasters, we also have aging. So it's not only that the disruptive event can happen, it's like it will happen with time just. But if we consider the resilience as the ability to recover, then this knowledge which we gain through monitoring, and through monitoring since the stage 0, so since the beginning of the new element, we will be able to assess the performance of the structure, and we will be able to enhance such ability to provide the information which is necessary to confirm if this or another infrastructure object can remain in use without any additional measures, or if there is a lot to be done after a disruptive event. That's how I will summarize it.
Thank you very much, Katarzyna. I am seeing that Paul is taking a note. Maybe you want to give a counter reaction to the reaction. Okay, one is demanding an answer. So.
Well, first of all, a short remark regarding aging. There are, of course, many cases where aging results in a deterioration of the resilience of the structure, but there are some cases, especially in foundations, where aging can also result in an increase of bearing capacity, for example, of a foundation. But that is just a short remark. I fully agree with Katarzyna in terms of monitoring, which is a very important aspect of it. But of course, the next question, once I have the data from monitoring, is of course, and what am I doing then? So if I discover that I have a problem with a certain piece of infrastructure, then of course the question is, what should I do about it? And if we change our approach to designing infrastructure, we may already foresee, when we build the infrastructure, ways to add additional measures, whatever they might be, to increase resilience. So basically we say, okay, we built a railroad. We put in a certain structure underneath it to make sure it has a certain serviceability. So that means deformations do not exceed certain limits. But of course, I try to optimize this, and I put a monitoring system in place. And then, of course, comes the results, and I see, okay, I have a few spots where I'm exceeding this. And if I have not thought about what to do then, it might become very complicated. If I have thought from the very beginning that, okay, I know my solution is probably very, very close to the limit, so I might exceed it in some places, and that means I need to foresee already then something I can easily do then to remediate that. That's probably something that could help. And of course, the third thing is, and that's also something we have discussed a little bit during our breaks, is risk sharing. So that means who is then responsible for that? Is it the contractor because he has optimized everything to offer a cheap price? Or is it something that is a joint effort? And of course, the risk of this joint optimization effort is then shared by all parties in that project. And that is, of course, something that is contractual and legal. So that's not something that can only be answered here in an academic circle. That's also something where we need lawyers and contract people in that, because all those aspects are also very important.
Thank you. I think
I wanted to react to the reactor.
yeah. I was about to ask, are you
Just a short comment. What you said about monitoring is perfectly fine. It looks like the observational method moved not only from the construction state but to the life cycle of the infrastructure. But I think that what we could do is even more than that. And who was saying it? Was Blaise saying about automatic doors closing and things like that. So I cannot find an example now. Oh yeah, I can find an example. For example, global warming is affecting infrastructures because of landslides, debris flows, snow avalanche, and so on. So we can detect this kind of phenomena, and we can protect the users, so reducing the risk of the users of an infrastructure, or if it's on a user, maybe an energy infrastructure, by doing something automatically after the detection, which was your idea in principle. So this is still monitoring. So it's a different use of monitoring. And as I said, it's an opportunity. If I have to reconstruct, because of deterioration, I have to reconstruct a lining, I can fill it with fiber optics, for example, and this will give me information continuously, and I might use this information for other means, not only that of understanding when it is deteriorated again.
Here I need to react. You can get the data, of course, you can install the monitoring devices, you can get the data, but you're talking from kind of an academic point of view also, because we like data. And the infrastructure owners, they don't like data. They hate when they get data from us, and they even don't like the data in the graphical representation, which is even a bit easier to understand. The only thing which they want is they want to get a green light, a red line, or an orange light. So they want to know if they need to react or if they can wait. Yeah. So I would say that the data are very nice and we like it, but
Yeah. No, infrastructure managers, we are not that simple, but quite. So that's one of our problems, not having so many data, but of course, I have been in a meeting a few weeks ago talking about trucks, not the infrastructure layers, talking about truck, but we were talking about sensing, about drones, and our main problem was, what do we do with so many data? What do we do? And that's a problem. We like the data, but we need help to analyze it and to take decisions, and that's the problem. And other question is sensing technology mature enough? Because we have some field tests with fiber optics sensing, but I'm not sure that if it's really mature, if it's really developed, or it's only in test. So those are our main questions. It's mature enough, and what do we do with so many data? We need simple things.
Okay. Yeah, I was about to open the floor for the audience.
Can I make one comment?
Yeah, okay. So first Jan, and then I think Yanis, you want to comment later? Yeah, okay.
I think
Yeah, wait a minute. So Jan and then Yanis.
going in line with what the last two contributors said. You get a lot of data and you want basically a simple answer. But for tracks, for example, it's also simple. You know how much deformation you can allow. So you know when to react. A lot of stakeholders, they measure for the sake of measuring. And the main reason why they measure is because the authorities allowing them to build something or keeping something requires measurement. So they have tons of data, but they actually not even look at them. It's the authorities who are happy. Now we have data on deformations. We buy satellite data every half year from the satellite passing by. Then the companies can show that to the authorities. Everyone is happy. No one is using the data. And they're not even willing to look at the mechanics behind the data. Why is some deformations happening? Why do pore pressures rise, etc.? And if they find something out of the normal thing, they basically say the sensor is broken. So they don't even analyze the sensors. And I think that's the main problem with all of the sensing. We have a lot of data, but everyone is more willing to believe, oh, the data is crap, rather than analyzing the data.
Okay, thank you, Jan. Yanis?
So I think it's clear that they don't like to look at numbers, Jan. They like to look at colors. So right, it's correct, right? It's better green, yellow, red, as you said. I think another problem is maintenance, because I like the idea of Katarzyna to have like a black box for every structure. So if something happens, you have a monitoring system and you know what happened. And you also do the health monitoring and you see how it deteriorates in the future. But a big problem is maintenance. So even if you convince someone to install the system, there has to be a provision about yearly maintenance so that the system is working. So I think this is one big part of the problem. There needs to be like a yearly fee, something like this, and somebody has to come and maintain the system, because if you don't, it will not work.
Okay. Yeah, Jose?
While he takes the microphone, not only maintain, but also dismantle. It's me speaking, Marco, hello. Not only maintain, but also dismantle at the end of the life cycle. This is something people are talking about. When you design, you already design with like a Lego structure. At the end, you take it away.
Yeah.
Sorry for being so boring about Eurocode 7, the future generation. But yeah, Paul is also engaged with this, so I guess he knows many things about this. But in the future Eurocode 7 Part 1, there is some requirements for the designer to make a monitoring plan and a maintenance plan. Although I am not saying that as is only written in the code, everything is going to be going well, but at least is something is required in the code. So let's see in the future, because some of the questions that Paul has said that I don't know, or the other person, I don't know the name, that if we monitor something, but we don't know how to do with those numbers, but at least theoretically, in the project, the designer should say something about the limiting values of the specified thresholds and limiting values for such and such. So at least the code writers or code drafters know about this problem and have written things about this. I don't know if in the future the designs and the projects are going to fulfill all these requirements, but are requirements. At least. So it's a positive way to see that the future, perhaps in the code, we are talking about later in the code. In this case, perhaps the code is a bit ahead of the practice. Let's see.
Yeah, the short answer from my side is I don't know either. I have seen those requirements in part one. I know that today, most of the time for what we do, there is no maintenance plan in place. It's not even written. That's also clear. I wanted to say a little bit about the data. I mean, we are looking, or we try to implement monitoring data, geotechnical monitoring data very often. But I think the owners of the critical infrastructure, they look at different data. I mean, a rail company, for example, they start to look at their track when they notice, oh, when I'm passing with the train over this section, there is vibration, or when I'm inspecting it, I see much more wear and tear on my track than I expect, and then they start to think about where does this come from, and then it's basically cascading down to, oh, that might be a reason somewhere in the ground. So it might be in terms of monitoring that we are not very good at setting up a proper sequence of monitoring. So where to start, at what to look first, and then second, and then third. So, and that is probably a bit of a communication problem between the ones using that facility and us as geotechnicians designing and building it. So maybe we need to improve our communication and our interfaces there to become better at that.
Okay, Marco, not that I want to throw you out, but it's already 1 minute, so maybe you have any last comment,
I will say bye-bye to everybody, but I asked, do we need to quantify resilience? What do you think from the industry, from the administration and so on? Is it a work worth of doing it, or it's useless?
You quantify happiness, for example?
I have a few answers to this.
Okay.
No, people have tried to do that. So
Yeah. In social science, they are quantifying that. Yeah.
We don't have in our community a common definition of that, maybe, but people have tried to do it in other communities. So I think
It's just that
we can think about it. Who knows?
Yeah, maybe there also the reason for that is because resilience in geoengineering is quite new. So it was long been used in ecology and in social science, but it's a very new concept in geoengineering community.
That's right.
Yeah.
But in social science,
It was long. You
can imagine if they did it in social science, maybe we could try to do something.
Okay, I will email you. You have to go. Your taxi is waiting.
Thank you. I'm very sorry.
Bye. Thank you, Marco. Is there any other question in the audience? How were you raising your hand earlier? And
Yes,
there's another one.
I was. One question, because in the previous session, we discussed about how can we make the gap between research and application a bit smaller, and how can we find simplified approaches and models. And you, Blaise, you raised that as well. So you need simplified approaches which are ready to use, let's say. My question now is, how can we assure that these models, so if someone develops such a model, that it really then reaches the state of a practice? Because I see several such models, but still they are published somewhere in papers, so, and maybe brought to a conference. But how can you ensure that then they are also not only accepted, but also then in the end, let's say, bankable, so that like a railway owner says, okay, you are allowed to apply this practice because I also know these papers, I trust them. Because typically we trust on those models which are 20, 30 years old, because then by the time everyone has heard about them if they are really good. But this is a long time span. So what can we do to improve that so that they are accepted?
Wait, that is addressed to Blaise in general.
Or to Rosa. Yeah.
Okay, can we just note that, and if you can later talk to each other when it's coffee break, because I need to ask a question. I want to ask a question, important question. But But there's another one, so you can please.
I have a remark for the monitoring. Let's say we have two kinds of monitoring. The one for the one who has to design the mitigation measure to improve the resilience, and the one from the owner who has to understand his track from a global point of view. That means for railways, for example, we need to have the whole track, to understand the whole track and to know which mitigation measures comes where. And then we tell that we have a problem, and then the industry says, okay, for this place, we need another model, another monitoring, more measurements, and then we know what is really good for this situation. So it is a communication problem, but often it is also a level problem because we need different models and different measurements to solve the problem. That makes it difficult, yeah.
Because I stopped him, so can we also just discuss it later? It's just that there is
maybe just one short comment. I think one key aspect for implementation is that when we start a research project trying to design a new framework, is that all involved parties are there. Meaning that infrastructure owners are there at the table, and also authorities are there at the table, so that we can discuss the expected results and the format of these results very early on in the research project, so that the product in the end has a format that is then easier to accept and then implement in official guidelines or building codes. I think this is probably a key success factor for that, because research sometimes does research on its side and gives results, but oftentimes these results, they are not in a format that we can reuse or easily implement to make it applicable in practice.
Because I gave him the backup one. You can also know. No. Okay.
Can I also just give a small answer to your question? From my perspective, which is a more modest critical infrastructure owner, it's that we have sometimes research groups that come to us with, for example, a new monitoring system that they want to try, and we allow them to freely install these systems on our bridges, and for a while to monitor the bridges and see if it's a feasible system. So this is also a way that owners collaborate with research groups. And this is quite useful because it's the most one-to-one experiment that you can have.
Thank you. Maybe as a last question, and because this is an important question for us in GeoLab, as you know, we are always, so in GeoLab, we are always saying that we want to address real life problems, and so that it is really fitting the needs of the society and everything. But this is only something that we could achieve if we have the participation of our target, target sectors, for instance, And in the in the past, as far as our assessment is concerned, the participation is quite low, for instance, specifically from CI owners and policymaker in particular. Industry is quite okay. Academia is really, really good. But the two are really quite low. So I think my question is, how do you think can we increase, the participation of this sector? What could we do from our side so that, to increase this participation? And this question is not only for the two of you, so to other CI owners and policymaker there in the audience.
I think the main question is increasing your visibility, because if you don't have visibility, infrastructure managers don't know you. I knew about you when I was invited to this to this project. So I don't know the way to do it. And maybe social social media, maybe through LG, maybe contacting directly with infrastructure managers in any country. I don't know how, but you need to be known among the infrastructure managers. I don't know if you from SBB or you also an infrastructure manager, what do you think about that? I don't know if you knew in the past about the GeoLab, but I think they have to reach us to be known and to be applicable. But so you can.
Yeah, I just know because my colleague from SVB, he's not here, but but he's from the science community, and because he was from the science community, he told me that it could be interesting. So I came because I have time, but normally they don't have. Yeah. Normally you don't have time to come.
That's not a problem for us, the time, because we are on our daily work and we don't have time for these important things.
But I think the rail companies, they have already one very well functioning system. Every country you have track alignment measurements and you have immediate actions afterwards. And if we as a scientist or as research centers can deliver products like the track alignment measurements, then it will be very easy to be applied by any stakeholder. So I think this track alignment measurements, they will be a very good example what the outcome of any research we're doing in terms of measurement and so on could be.
How about Blaise? Do you have any comment?
I think probably the fact that the different stakeholders get together for some formal occasions to exchange their needs and possibilities is a way to put research forward. So I know in Switzerland it's easy because we're a small country, so we meet everybody quite frequently. We know who is who and who's doing what. But yeah, try to something like today is a good thing because then we hear about the possibilities, we hear about the needs from different actors, and then we can make contacts. So I think this is a good thing, and I think also the policymakers and CI holders, they need to express their needs as well in some formal way, saying, okay, me railway company, my problems are this, and this, and I'd like to see some research in this field. And then research institution can take on that and say, okay, I've seen you have this problem. I'd like to do this kind of project. So somehow we have to have mechanisms to exchange our possibilities and needs to create more interaction.
So we are, okay, last.
Yeah, I think it's good to increase the visibility and to collaborate together. Mm-hmm. If you see, for example, in research, you develop one model, you see that something is missing, you work on and structuration, this, and then you're just pushing through that line. But if you also, as a researcher, look into the real problems that the society needs, that needs to be delivered, then there is huge potential to see something and then work. And then there is also lack of communication. Generally, the research sometimes goes for its own world and then the practice is going to other things. But bridging this communication is important. For example, at NPRA, we have been investing in some researches. Sometimes you get end results that's not easy to use it in your daily routine. Nowadays, we are involved from the beginning of the research because implementation starts from the start. Then there is communication that guides it throughout the process. Then we are in a way to use the end results, at the same time also give valuable feedbacks to those who are developing. Yeah.
Thank you very much. So what I'm getting from this is that there is really a need for strengthening exchange and communication between GeoLab and the target sectors and within the sectors. So this is something that we could try to improve in GeoLab. And with that, I end this session. Thank you very much to our speakers and reactors. You have been really great. Thank you very much.